Welcome back. I hope you have watched the previous part of selection sort algorithm. In today's video, we are going to optimize our selection sort algorithm's code. So, the main problem in this code is the useless execution of swapping line of code. To see how this useless execution is performed, we have to dive into the depth. Let's suppose we have an array in which elements 10, 20, 30, 40 are present. I and min index pointers are pointing to the first index of the array, which is 0 here. J pointer is pointing to the index, one more than the index which is I and min index pointers are pointing to. When we will run our algorithm, at here, the comparison of element 20 and 10 will be performed here. The if statement becomes false, so the code that fall under the if statement will not execute, indicating that min index pointer will be pointing to the same index as previous. Now the control will go to the next statement. Here, the swapping operation will be performed. Element of index, which is I is pointing to, will be swapped with the element of the index that is min index is pointing to, which is 10 here for the both indexes. So, element 10 will be swapped with itself, which is meaningless. So to avoid this meaningless swap, we will swap the two elements only when the values of min index and I pointer will be different. For same values of it, swapping will not be performed. So let's see it again after optimization. The elements will be compared again here, and if statement will be false here, and under it, no code will be executed. Now control will go to the next statement. Here it will be checked that if the values of I pointer and min index are same or not. In this case it is same, so no swapping will be performed. And the control will go back to the for loop, which will increment the value of I. During the comparison, if it is found out that the element which is G is pointing is smaller than the element which is min index pointing, then the min index will point to the index as same as the index J pointer is pointing. So now let's find out the number of swaps done. For each execution of this loop, swapping line of code is executed one time in worst case, meaning that the initially array was fully unsorted. So the worst case complexity would come out to be the big O of n-1. The best case complexity for swapping done will be 0, because 0 is the only minimum number for execution of swapping line of code, meaning that array is already sorted out, and there is no need of swapping. Selection sort algorithm is preferred when the swapping operation is way much costlier. So, this was our video about the optimization of selection sort algorithms code. In upcoming videos, we are going to learn about the merge sort algorithm. Till then, keep grinding.